let's do a few more right triangle solving questions using SOHCAHTOA. So looking at the second example in the packet, here we're given a triangle where we have the two legs of the triangle being 4 and 7 inches each, but none of the angles. So here, I always would think about what do I know and what am I trying to find? Well, I want to find the two angles in the triangle, neither of which I could, well, actually, I could solve these right away. Because if, let's say I was trying to find angle B, let's call that theta, I could use the tangent function to find theta because I know the opposite and adjacent side. So tan of theta is equal to 4 over 7. And then I could use an inverse function to approximate the value of angle theta, and go ahead and type that in my calculator. So let's go ahead and do that. Arctangent of 4/7 would give me approximately 29.7 degrees. And cool, that part's done. And another thing that I wanted to mention about triangles is that when you're solving triangles, the answers you get should pass what I like to call the smell test. Does this smell good or does it smell funny? Like, does this look about right or no? In this case, this angle seems about right, like based on, okay, 30 degrees. I know 30 degrees is the smallest angle in the unit circle, 45 is in the middle. You know, it's a 1-to-1 ratio, where 60 degrees is a little sharper. It should seem about right. And also, assuming that the lengths seem about right, everything should make sense. So when I'm solving a triangle, I can kind of have some common sense. Okay, does this answer make sense to what I'm looking at or not? And it's a good way to kind of check yourself along the way. But anyways, also, once I find that first angle, the second angle is always complementary to that. Since I know the right angle C is 90, and they all have to add up to 180, that implies that the last one has to be that these two have to add up to 90, or that this one is just 90 minus this one. So it is going to be 60.3, right, to find angle A. So once you find one angle, the other angle is always really easy, subtract from 90. And also the hypotenuse is the last unknown. That I could have done without trigonometry, though technically you could use a sine or cosine function to solve that, but you could always just use the Pythagorean theorem to find the third side. Just, as we normally would. 4 squared plus 7 squared is equal to c squared. And my recommendation is always try to use the easiest method, because SOHCAHTOA is pretty easy once you get it, but it's a little bit more complicated math because we're using inverse trig functions, which, as we studied, are not the simplest things, especially to do without a calculator. But the Pythagorean theorem and the complementary angle theorem, or really it's called the interior angle property. There's no such thing as a complementary angle theorem. I just made that up, but you know what I mean. Those are easier formulas. Those are things we could do without a calculator and solve. Well, that's 16 plus 49, which is 63. So c must be equal to the square root of 63, which is approximately, again, we really do want to use a calculator if we want to get a decimal approximation of that value, but we could figure it out exactly even without a calculator via Pythagorean theorem. But, we could find the hypotenuse length, which is approximately 7.94 inches. And the units on the lengths of the triangle, it also doesn't really matter if it's in feet, meters, inches. It would all be consistent. As long as all the units are the same, it will all work using SOHCAHTOA and the Pythagorean theorem, as long as there's consistency. And also, as I said before, you could actually build this triangle, take some construction paper, a ruler, and a protractor, and make a right triangle with a ratio of 4:7, and measure out everything else. You'll see that it will all work exactly as we've been calculating using our trigonometry, which is kind of a fun way to do this. And a project that I was planning on doing with you guys in class, but we obviously can't do this because we are all stuck at home, is to just have a day of making triangles and kind of give you guys some credit for a project where you could build a few triangles with construction paper and apply all of these rules to actual triangles. Now, actually, I do have a trigonometry project for you guys, but we need I won't assign it till we're finished with chapter 5 completely. So that will be coming. Anyways, let's do one last triangle and then I'll wrap this video up. So in this triangle, we're given an angle B and side C. I'll go ahead and call this angle C just as kind of a standard convention. The right angle is usually angle C because the opposing side is the hypotenuse. We just usually use C for that, though it doesn't. Technically, you could use A, H, and an O for adjacent, opposite, and hypotenuse as well if you prefer. But just a little thing to be careful about is if I'm using adjacent and opposite, notice that both A, B, and C, when you're using the Pythagorean theorem, doesn't necessarily agree with the adjacent side and the hypotenuse. But anyways, that's not that important. Just make sure if you're using SOHCAHTOA, you're using the correct sides based on the angle at hand. Like in this case, I know angle if I know one angle which we could call theta. Well, and again, that always implies that the secondary angle would be opposite of 90, so 23 degrees based on interior angle property. But basically, I only know one side. And in these cases, we always want to use, well, a trigonometric function. Since I know, in this case, I know the hypotenuse, I want to either use sine or cosine. I don't want to use tangent. Because if I was to take tangent of 67 degrees, I don't know opposite or adjacent, it's not gonna help me. But either sine or cosine could help. So let's say I started with the cosine of 67. The adjacent side to cosine would be this one. So again, that would be side A, and this would be side B. If I was naming them using the same as the angles. Sorry, my printer is printing. I don't know why. I did not tell it to print. But basically, it would be the ratio of adjacent to hypotenuse A over C, based on SOHCAHTOA. And I know C is 42. So again, in this equation, I know 2 out of 3 parts. I know theta, I know hypotenuse, I don't know adjacent, but I could solve for adjacent by multiplying both sides by 42. So if I took 42 and multiplied by the cosine of 67, that would give me the adjacent side, which I could type into a calculator. Since 67 degrees is not an angle that we have on our unit circle sheet, but in any angle that which we don't know, we could use a calculator for, and that would give us approximately 16.4 for the length of side A. And that passes a smell test. That smells okay. About 16.4. And then the third side, I could then solve either using tangent or sine or Pythagorean theorem. Since a squared plus b squared must be equal to c squared, that means b would be equal to the square root of c squared minus a squared. So if I'll go ahead and calculate b real quick. Square root of c squared minus a squared, which was the answer I just calculated, would give me side b from Pythagorean theorem, which is approximately 38.7. But anyways, that is a few examples of solving triangles, and a reminder that when you're solving triangles, you want to solve everything you can about them. Not just the sides, but the angles, and find all 3 sides and all 3 angles. Now we know everything there is to know about it, well, minus the area. We'll talk about that in a later video, and there's other properties as well. But when I say solve, that's always what I mean. See you next time.